Okay, the dot product between the two vectors I did show you. Now I have three vectors u, v, and w. We want to do the operations on them. Negative 3v means simply multiply that negative 3 by v. V is 8, negative 4, and 3. So negative 3 gonna be multiplied by each of this. Negative 3 multiplied by 8 is what? Negative 24. Negative 3 multiplied by negative 4 is positive 12. Negative 3 multiplied by 3 is negative 9. So addition of the three vectors, simply you add x, y, and z component of them. So x of the u is 2 plus x of the v is 8 plus x of the w, which is negative 6. So y is 3 here, is negative 4 here, and here is negative 2. Z is negative 5, here is 3, here is 0. So it's going to be 4. Here going to be negative 1, negative 3, negative 5 plus going to be 2, negative 2. So next question is u minus v. U minus v, you just simply the component of the u, which is 2 minus that. So it's going to be 2 minus 8, 3 minus minus 4, negative 5 minus 3. So I just simplify. It's negative 6, it's positive 7, it's negative 8. Now I want to find the magnitude of this. Everyone know that the magnitude is going to be square root of negative 6 power 2 plus 7 power 2 plus negative 8 power 2, right? So if we do the magnitude, it's gonna be 149. Square root of 149. That's it. U dot v, again, u is 2, 3, negative 5, dotted to the v, which is 8, negative 4, and 3. So for dot product is x component multiplied by x component, y component multiplied by y component, and z component multiplied by z component. That's going to be what? It's going to be negative 11. Okay. So next question, determine if A and B are colinear. So if they multiply with each other, they're colinear. So I want to see if the 6 over 9, so x component over x component, also y component over y component, and z component over z component. I want to see if their ratio are the same or not. So to simplify, divide by 3 is going to be what? 2 over 3. This is 2 over 3, and divide by 2 is going to be 2 over 3. So they are the same. So therefore, these two vectors are what? Colinear. There is another way, just using the dot product between these two vectors, finding the angle between these two. And if the angle is 0 or 180, they are colinear. Anyway, find a vector orthogonal to that. I know that if the vector is orthogonal, A and B is orthogonal, dotted product between them should be 0, right? Let's say the second vector is x, y, z. If these two are orthogonal, the dot product between them, let's say this is A, this is B, A dotted to B should be 0. So A dotted to B is 3x plus 4y plus 5z. I need to equal it to what? To 0. Now, I know that if I put x equal to 0 and y equal to y, I just set these two numbers, then I solve for z, right? So it's going to be 3 multiplied by 0 plus 4 multiplied by y plus 5 multiplied by z is equal to 0. 4 plus 5z equal to 0. So you solve for z, that's negative 4 over 5. So my vector kind of gonna be 0, 1, negative 4 over 5, right? If you don't like this in denominator, so just multiply each by 5. It's gonna be 0, 5, and negative 4. That would be orthogonal vector to the original vector. If you want to check, you just dot product that, you should get 0. Okay, next question. Example 9. A crane lifts the beam upward with a force of 5,000. So this force, I call it force 1, is gonna be upward, right? Means the x and y is 0. I just have a z component. F2 is gonna be into the west. West, if you imagine that Cartesian, so this is for z component is gonna be up, down, right? For y component gonna be east, west. For z component gonna be what? North, south. So therefore this is gonna be west, means this is y component, so it's gonna be negative. So 0, y component is negative 6, 5, because it's at west, and 0. And F3 is that north 650. Another worker apply the force toward the north. North means x direction, so 650 positive, 0, 0. I want to find the total magnitude. So these 3 workers apply force 1, 2, and 3 on an object. I want to see the total force. Of course, the total force is going to be addition of that, F1 plus F2 plus F3. I put a vector sign above all of that. So if you add these 3 vectors, the x component need to add up, so it add up to 650. The y component need to add up, is add up to negative 650. And the z component need to add up, which is 5,000. Now I want to find the magnitude of the force total. I call it force total. Magnitude of the force total is going to be x component power 2 plus y component power 2 plus 5,000 power 2. So if you do this calculation, get 5077.6. So the magnitude of that is going to be Newton. Okay, I want everyone to go to the page 399. Page 399, 400 and 401. Do the related questions for me and email it to me.